What's it made of? Let's find out.
Hi, I'm Eric Miller from Northwestern University's NUANCE Center, and you're watching
What's it made of?
the YouTube show where we take normal everyday objects and put them in an electron microscope in order to find out what different elements our sample is composed of. We had a suggestion from a viewer to find out how much gold, if any, is on a 3.5mm audio jack. Well, I'm sorry, we can't do that. But I do have this gold-plated HDMI connector that we can totally look at instead. So I didn't do anything fancy with this. I just cut one end off and then polished it a bit so that hopefully we can see any layers that are present on the connector. What I'm going to do is put the sample in the microscope slightly tilted so we can look at both the polished face of the connector and this unpolished gold area here at the same time. So let's find out
What it's made of!
So we put it in the microscope and fire up the electrons. Here we can see our sample, and we'll go up in magnification and look at this area here. Like I mentioned before, this is tilted a little. So this is the polished face here, and this is the unpolished gold-colored surface here. Now, if we turn on the energy dispersive X-ray spectrometer, we can determine what elements are present in the sample. The main body of the plug is iron, which makes sense. Steel is tough, it's cheap, and it's electrically conductive. The next layer we can see is copper. We can see we have another layer on top of the copper though, and that looks like nickel. Now we can see we're picking up nickel from the polished face of the sample, but also from here on the top of the sample. Now we know that nickel is silver colored and not gold colored, so there must be some other very thin layer of something on top of this nickel here, and we can tell that this top layer is very thin because all this nickel signal is showing through it. So let's find out, is it real gold on top? Yes! So how much gold? Well, obviously not much, since we can see so much nickel showing through it. Based on how I polished this sample, and that we can't see the gold layer in the cross-section, I'd have to say it's probably less than 1 micrometer thick, which, as we like to point out here, the hair on your head is about 50 to 100 micrometers thick. So anything less than 1 micrometer thick is pretty thin. So why are all these layers here, and what are they all doing? First off, they're all electrically conductive, which is great since they're in a plug. That's exactly what they need to do, conduct electricity. But why all these layers of different things? That's a good question. I'm glad I asked it. First off, why a gold coating? Gold has the best electrical properties of any metal, period. But it's super expensive, so we're not going to make a whole plug out of solid gold. That would just be stupid. The surface of the plug is the most important part, so that's where we're going to put the gold. Now, apart from being great at conducting electricity, gold is also very malleable, or soft. That means that when we plug our connector in, the gold-covered surface will deform just a little bit, and that helps make the connection from the connector to the plug a lot better. Steel is cheap, so most of the plug is made of steel. Gold is expensive, so there's just a tiny little bit of it. So why can't we just stick the gold onto the steel and then be done with it? I mean, why do we have to have these layers of copper and nickel? Well, if you remember in one of our previous videos about cheap jewelry, we talked about the electroplating process, which is most likely how these extra layers were put down on top of the steel. Well, in the electroplating process, the material you're coating and the material you're coating it with actually form an alloy of the two materials, which is how they're able to stick together so well. The problem here is that gold and iron do not alloy very well together, or at all. So we need a buffer layer in between the gold and the iron. Copper is usually put down as an adhesive type of a layer. It will stick to just about anything, and just about anything will stick to it. But if that's the case, why is there this nickel layer on top of the copper layer? Why can't we just put the gold on top of the copper? Well, as it turns out, the copper and gold get along a little too well. And if we put the gold layer on top of the copper, the gold atoms will get sucked into the copper. This process is called infiltration, and we don't want it. Instead of copper and gold, we'll end up with a mixture of something like gopper. Gopper is not a real thing. So we have a nickel layer here on top of the copper layer to prevent the gold from infiltrating the copper, or vice versa. Who knew that coating something in gold was going to be so complicated? There we have it! Fascinating! If you have something you want us to take a look at, just put it in the comments section below. From Northwestern University's NUANCE Center, I'm Eric Miller, and we'll see you next time.